Good morning, my dear Year 10 students. This is Miss Teresa presenting to you a video lesson about reflection. Our success criteria for today is to describe the formation of an optical image by a plane mirror and give its characteristics, and recall and use the law angle of incidence is equal to angle of reflection. What is reflection? When a ray of light approaches a smooth, polished surface and the light ray bounces back, it is called the reflection of light. Any type of wave can be reflected, not just light. It could be sound, water wave, and of course, the most famous light wave. Reflection best occurs on flat and hard surfaces, let's say a mirror. So let's say this is a light wave. This will be reflected this way, okay, as we all know. Now, I will tell you about these lines and rays later on, what the names are. And how about if we have a water wave? Let's say there's a barrier, okay, and this is a water. Our medium is water, okay. But water does not have just one line. We cannot just take one ray of water wave. It would be a series of wave fronts. I talked about wave fronts yesterday. So if wave fronts approach the barrier at this angle, okay, that's a barrier. Now it will follow the reflection law of reflection. So it will be bounced back this way, and this is the incident wave front. This will be the reflected wave front. Now sound will also follow the same law as light and water wave. Okay, so let's move on. Here are the words that we need to know about reflection. So we have normal, incident ray, incident angle, reflected ray, and reflected angle. After I discuss this, you have to write the definitions on your notebook. So let's say we have a barrier over here, okay, and we're going to draw a normal line. Okay, let me do that again. Normal line. The normal line is an imaginary line perpendicular to the reflecting surface. The reflecting surface can be any hard surface like mirror, or a shiny surface like our, let's say, surface of our refrigerator, a glazed window, a whiteboard, and so on. So a normal line is a line which is imaginary perpendicular to that surface. It is important because it is where we measure our incident angle and reflected angle. Now if we have a source of light over here, let's say this is a source of light, okay, and we have a ray of light which is directed to our reflecting surface, and we have to denote that with an arrow just to show the direction of the light. Okay, so this is called this ray is called our incident ray, okay, and that incident ray forms an angle with the normal, okay, because most students have the misconception that the incident angle is this one. No, this is not the incident angle. The incident angle is the angle formed by the incident ray with the normal. So this is our incident angle. Let's say it's 30 degrees. Okay, now that incident ray will be bounced back by the shining surface, and it will be this way, denoted by two arrows which will indicate the direction of the bouncing back of the light ray. Now this angle is called reflected angle, and this ray is called the reflected ray. Now the reflected angle will also be 30 degrees. Okay, so that's normal, incident ray, incident angle, reflected ray, and reflected angle. You have to write down the definitions on your notebook. You can pause the video if you want so that you can write it down. Okay, moving on. Now there are two laws of reflection. First one is the angle between the incident ray and the normal is equal to the angle between the reflected ray and the normal. It just simply, it says that angle I is equal to angle R. Angle I means incident angle, and R means reflected angle. So angle I is equal to angle R. So if we will draw that, Okay, this is the normal. Now this is our incident ray, and this is our reflected ray. This angle I, is equal to this angle, which is angle R. Okay, that's the first law of reflection. Now, how about the second law of reflection? The second law of reflection indicates that the incident ray, the normal, and the reflected ray are all in the same plane. So if we are going to draw that again, it is obvious that they are all on the same plane. These rays, they can all be found on the same plane. The incident ray, the reflected ray, and the normal, denoted by big letter N, is found on the same plane. So that's, they are found on the same plane. Okay, moving on. What are the characteristics of an image formed on a plane mirror? First, it's virtual, it's upright, it's laterally inverted, and the image is formed the same distance as the object from the mirror. So let's try that. Let's say this is a mirror. Okay, so bear with me, sorry I cannot draw properly over here. And we have, let's say, an image, not an image, an object over here. Okay, this image, let's say we are going to draw one incident ray from this heart towards the mirror this way. Okay, and then we have to draw the normal line with the incident ray. Okay, so let's say that this is 30 degrees. Okay, now the reflected angle, the reflected ray will form 30 degrees also from that. Okay, and then with this reflected ray, you're going to draw a broken line at the back of the mirror this way. Now we'll use another angle, let's say this one, from the same point of the heart to the mirror. Okay, now let's draw another normal line over there. Let's say that is 60 degrees. Okay, sorry, it's being messy now. Now you're going to use your protractor to draw a 60-degree reflected angle over there, 60 degrees. Now that reflected ray, you have to draw backwards also a broken line. Now where they meet here is where your image is located. So this is your image and this is your object. So as you can see, it is virtual. What does it mean, virtual? Virtual means that you can find it at the on the mirror itself, not in front of the mirror, at the back of the mirror. Okay, it's not existing in the real world, so it's a virtual image. It's upright, same as the object. Okay, it's not inverted, but it's laterally inverted. What is lateral inversion? It means the apparent reversal of the mirror images left and right when compared with the object. It means that the right will become the left and the left will become the right. So that's lateral inversion. You have to write the definition down also. And as you can see, the distance here is equal to the distance here. Okay, the object distance from the mirror is equal to the image distance from the mirror, denoted by DO and DI. So that's equal. They are equal. So those are the characteristics of image formed on a plane mirror. Okay, so if you have any question, just ask me in the private chat. Let's move on. Now this is a question, IGCSE type question that you will meet about reflection. It's similar to the one I discussed in the previous slide. So this is our object. Okay, and the figure shows two rays of light from a point P and an object O. Okay, and these rays are incident on the plane mirror. This is our mirror. Okay, let me just clear that up. Okay, on the figure, continue the paths of the two rays after they reach the mirror. Hence, locate the image of the object O and then label the image I. So how we're going to do this? You need your protractor to do this, as well as your scale. You should not take for granted the usefulness, the significance of your scale and your protractor in this case, because you have to draw a very, very exact image, extremely exact image. Okay, so in this case we have the first ray, this one ray. Okay, we're going to draw, how to answer this, we're going to draw a normal line with that. Use your protractor to measure this angle, and then using the same protractor you're going to draw a reflected ray over here. You have to denote it with these arrows. Okay, now this should be exactly equal to the angle you measured over here. Do you understand? That is very significant. After doing that, you're going to continue drawing the reflected ray, but backwards this way, using your scale. Okay, now we're going to use another color so that we will be able to distinguish which one is which line is which ray is which. Okay, so the second one, this one, this is our next line. Draw another normal from that. Measure this angle using your protractor and draw a reflected ray over here using the same angle that you have measured. Then after that, you continue drawing backwards this way. Now where they meet, this is your intersection. The intersection of the two lines is where your image is, and then you have to denote it with I. So this is 2 marks, 1 mark for your drawing, correct angles and so on, and 1 mark for the image I, which is labeled. Without the label, you're going to lose 1 mark. Do you understand? Okay, so this is how you will answer it. Use a protractor and a scale to precisely locate where your image is. So on your notebook, you're going to answer this. I'm not gonna give you the correct answer for this here in this video lesson, because of course you need your what's this, you need your protractor and your scale to do this. Please print this out, not as a slide, you print it out as what's this, or you can just crop it from your screens. I know you know the snipping tool. Okay, you crop that and then you transfer it to an A4 sheet on your Word, MS Word, and then print it. I know you're technologically advanced and was this savvy. Please do that. Do not ask me for such things. I am a dinosaur compared to you. So that's what you will do. You answer this question. So let's go on. What is this? Okay, this is the reflection definition. So what have we learned today? We've learned today about, let's go back to our success criteria. So bear with me. Okay, today we have learned to describe the formation of an optical image by a plane mirror, and we also gave its characteristics, and we used the law, angle of incidence and angle of reflection in drawing our image and drawing this, that is called actually ray diagram. Okay, so that's all for our reflection lesson today. It's quite short compared to our lesson yesterday. I hope you enjoyed today's lesson as well. And this is Miss Teresa signing off. Hope you enjoyed. Have a nice day.